Napoleon, like anyone can even know that.
Hello friends, welcome! Today we'll continue on our journey of privilege escalation, specifically by way of found credentials. So found credentials is kind of as simple as the name implies. It's when we use any one of a number of different enumeration techniques to basically discover the credentials which we can use to elevate our privileges. Now, it can manifest specifically in a number of different shapes, all really depending on the level of complexity. It can be as simple as finding a text file called password.txt on the user's desktop with a password right there inside of it. Then slightly more complex, perhaps we can run specific enumeration commands and we can discover a clear text password. So we might look at the console history and discover that in the past, somebody set up a port forwarding and they ran a command which contained the clear text password. Or, as we'll see today, we can also run specific enumeration commands against the registry, which can then sometimes reveal the clear text password. And then beyond just running enumeration techniques, we can also do different things like, for example, dump the SAM database. And then if we run a script like secrets-dump.py from the Impacket framework, it might reveal hashed credentials, which we can then hopefully crack. So as I mentioned, today we'll be focusing on the enumeration technique to find credentials, and we'll specifically be applying it against the HackTheBox machine called Chatterbox. Now before we get to privilege escalation, of course we need to get a foothold on the machine, and in Chatterbox we'll do so by discovering a vulnerable service called achat, against which we'll run a very basic buffer overflow script which will give us a reverse shell. This is a super fun box with a lot of good little lessons in there, so for that reason I think it's enough with all this flippin' dilly-dallying, and so let's get to it. Yeah. Okay friends, and so we find ourselves here in the terminal, and not too surprisingly, we're gonna start out with an Nmap scan. And typically, as you've probably noticed in the past, I like running what I've now learned is called the IPsec scan, which is with TAC-SC and TAC-SV. And so we'll do the same basic scan today, the IPsec scan, but we'll also layer on a few more options. Nmap. And the first thing I'm going to do is actually set the speed, and that's T4. Now typically if we didn't specify what speed we wanted to scan at, it defaults to T3. So T4 just says that we're going to be performing a slightly more aggressive scan. And the reason I'm basically doing that is, we will again enumerate for standard scripts, as well as try to enumerate versions, but I'm also going to run -A. Now with -A, it just becomes a more comprehensive scan, as we now also enable operating system and version detection, script scanning, and traceroute. In addition to TAC-A, I'm also going to do TAC lowercase p TAC, and all that is telling Nmap is to go ahead and scan every single one of these 65,535 potential ports, right? So usually, again, if we don't specify it, it will default to the top 1,000 ports. And so if for whatever reason we do believe there might be some unusual ports or rather unusual services running on the target system, we can also provide TAC-P TAC. Now here's the thing, friends, because I added these two flags, the scan can take quite a long time, and it's for that reason that I also added TAC-T4, just so we can speed things up a bit. Right, enough with the talking, let's go ahead and scan Chatterbox.
A few moments later.
Right, so here we can see our results. First, we can see port 135, and that's where RPC will be listening for incoming requests. After this, we have port 139, and 139 is, typically used for file and printer sharing and other NetBIOS services, specifically over SMB. And then we also have 445, which is also SMB, but that's if we want to bypass NetBIOS layers. So in a sense, you can think of 445 as just kind of a more modern version of 139. And then here in the bottom, we can see all these other kind of more unusual ports related to RPC. Let's kind of just forget about that for a second. And then here we see something quite interesting, and it's port 9255 and 9256. And we can see that these are the ports reserved for something called achat. And now, if you don't know what achat is, you're not alone. I'd also never heard of it, and I had to look it up. But basically, achat is just a software application used for instant messaging, hence the chat, as well as file sharing over networks. And it used to be something moderately popular in corporate environments, but it's been abandoned to a large extent, and the reason for that is just to numerous security vulnerabilities, right? And of course, given that, I think that's the best place for us to start, is to basically see if potentially we can find a vulnerability on this achat service and see if we can exploit that. And so instead of search exploit, I'm actually just going to open up the browser, and then I'll search for achat exploit db. And we can immediately see there are two basic hits. There's one for Metasploit and there's one without Metasploit, which actually turns out to be a Python script. Now friends, in the previous video, I kind of did a side-by-side doing with Metasploit and without Metasploit. I will kind of be returning to that in the future again, but I'm not always going to do that because it can obviously be quite cumbersome, and I'm sure it's going to bore the hell out of you guys if I always do it by two different methods. Now that being the case, when I choose to not do both approaches, I am going to default to doing the non-Metasploit version. And the reason being is, as I said before, Metasploit can kind of like take care of so many different things that it can actually cultivate numerous blind spots. And so just kind of a simple analogy that I thought of earlier when I was in the shower is I grew up in South Africa, and in South Africa, when you get your driver's license, you have to learn with a manual. You have to learn with a stick shift. And I think that's actually quite cool because when you learn to drive a manual, then even if you've never driven an automatic car, when you get in an automatic car, you're able to immediately drive it. And why is that? It's because an automatic car is just a simplified version of a manual car. But the opposite is of course not true. If you've only ever learned to drive an automatic vehicle and I put you into a manual vehicle, well, now not only do you have to change gears, but you also have a clutch that you need to operate. So your foot would have no idea what to do with this clutch. And obviously you haven't kind of developed the control to learn how to use the clutch in combination with shifting gears. Now I'm sharing this analogy just to kind of share with you guys. I think it's very similar with Metasploit. If you learn just to exploit using Metasploit, it's kind of like learning to drive with an automatic vehicle. And that's fine as long as you're always going to drive automatic vehicles, meaning if you're always going to use Metasploit. But the thing is, that is going to limit you in so many ways because you won't always be able to use Metasploit. Whereas if you learn a more manual approach, and if at least you have a basic sense of how Metasploit works, then it's very easy to apply the same logic and use Metasploit to run an exploit. In any case, so that was a very long-winded way to say that we're going to be doing the manual script here, but I just kind of wanted to share a bit of the underlying philosophy with you guys. Now here's the script, and we can obviously read here it's a remote buffer overflow, but we can also see here clearly, just by kind of virtue of what the script looks like, that this is clearly something that's meant to lead to a buffer overflow. So one kind of sticking point here though is that this is obviously developed for a specific version, and if you remember back to our Nmap results here, you can see that despite that we ran SC, SV, and A, it was not able to give us a version number. So that basically leaves us with two options. We can really dig deep and try our utmost to see what the version is and whether or not we're able to exploit it with this remote buffer. Or a path of least resistance that I prefer is we could just run the exploit and see if it works. And if it doesn't, then we can perhaps assume that for whatever reason maybe the version is wrong. And if it does, then we obviously saved all the time of not doing all this extra recon just to find out what the version number is. And of course, getting an answer isn't even assured necessarily in any case. And so back here, I'm just going to click here and download the script. So here back in our terminal, the first thing I want to do actually is just create a directory called Chatterbox. And I'll cd into Chatterbox, and the reason obviously is just so we can kind of like neatly keep everything together. And so first thing is I'll copy the script we just downloaded, and I'll save it here, and I'll just call it exploit so it's easier to remember, I guess. Next thing is I just want to make sure that we can actually go ahead and execute it before I forget. And so I'll do that. And then finally, I'm going to use the Sublime to open this in the GUI. And the reason I'm preferring that over Nano or Vi is simply we're going to be needing to select multiple lines and copy and cut, paste. And I just always find that slightly more cumbersome when I do that in the command line. So yes, I'm definitely outing myself as not a lead hacksaw, but I actually never professed to be one. So it's so cool. Okay friends, and so I'm gonna make this a little bit bigger. I'm just gonna quickly roughly explain what happens here. I'm not going to get into the nitty-gritty of what buffer overflows are, but what you can basically think is we're going to cram all these raw bytes into the memory of the program. We're basically going to fill it up, so it's going to overflow, hence the name. And when that happens, it's actually going to allow us to run any command that we want to run. And so in this case of this example we have right here, You can see this on line number 9. That's a commented outline. And what this current script will do when it runs, it will basically generate and then execute this payload. And all this is going to do is just open up calculator on the victim system. And so it could be quite easy for us to kind of just modify this part. And instead of that being exec, we can basically do a reverse TCP shell, specify the L host and the port number. We've done this many times before with MSA Venom, right? And that is one very legitimate option. And, you know, we could create a netcat listener, execute that, call back, and then yay, we have our shell. The one thing about that is we have a command prompt shell. And in this case, I actually want us to end up with a PowerShell shell.
She sells seashells on a seashore, but the value of these shells will fall.
Now, when we want a PowerShell shell, there's actually one additional step. And it's because this is not going to call back to us and automatically create a PowerShell shell, but instead we're basically going to tweak this command so that it will go and download a specific script, execute that script, and that script is going to then give us a PowerShell shell. And so let's just head back to our browser, and here in our browser, let's just write Nishang, which is the specific framework we want, and GitHub. And we can see our very first result right there. And so I'm just going to go ahead and I'm going to download the zip file. And so here back in our terminal, I don't know if you saw, but we obviously downloaded a zipped archive. So the first thing I want to do is just run unzip, and we'll unzip the file we just downloaded, which is called nishangmaster.zip. And we'll set the destination to our Chatterbox file. And we can see there that Nishang master successfully extracted here. So let's just go inside of it. And we can see here, as with something like PowerSploit, what Nishang basically is it's a collection of different scripts in PowerShell. Now in this case, as we said, we want a reverse TCP shell. So we can see there's another directory called shells. Let's just go inside of it. And we can see here a whole list of shells. I'll actually just run L. And we can see here, and the specific one we want in this case is called invoke PowerShell TCP.ps1. And now, just to make our lives a little bit easier, I'm going to go ahead and I'm going to copy this file. And where will I copy it? Well, I'll go back 2 directories and I'll copy it there, and I'll actually just call it shell.ps1. Right, so let's go back into that folder, and we can see right there that we have shell.ps1. Great, so once again, just to quickly review, we've just gone ahead and downloaded this additional PowerShell script so that when we run the achat Python script, right, the exploit for achat, it will call back and it will give us a PowerShell shell and not a regular command prompt shell. Right, so now it's time to actually generate our payload. So let's go back into Sublime, and we're just going to copy this entire line without the hashtag, obviously, because we don't want it to be a comment. I'll copy that. So let's go back to terminal. Right, so let's just go ahead and paste the actual command. But as I said before, there's a slight issue here, which is right now, as the command stands, the only thing it's going to do in the victim system is open calculator. And so obviously kind of in the hacker world or cybersecurity education world, that's kind of a proof of concept to show that something works. But in this case, not only would it be useless to us because we don't want to open calculator, but we actually have no idea whether or not it succeeds, because we obviously don't have access to Chatterbox right now to see whether or not the calculator app is going to open up on their desktop. Right, so we want to change this. And I'm just going to paste the new part right here, and we can run through it real quick. And so as we saw before, we have basically our payload being a Windows execution. This time, however, we will run a PowerShell command. And this PowerShell command is basically an IEX command, which you probably know this Cradle is incredibly useful because it allows us to download something, and right after we download it, we execute it straight into memory. And so here we can see that it's going to call back to us to our IP on 8000 and download shell.ps1. Now, before we forget, let's actually just create a new tab quick with Control Shift and T. Let's go into Chatterbox, and we can see indeed it's called shell.ps1. Let's just make sure that our IP is right. Indeed it is 10.10.14.11. And so I will use Python to create a HTTP server on 8000. Right, so let's just head back to our command. And so we can see just as we write, so that's our IP. And now that we have a Python web server running, this will go and basically come to our own machine and download that script. Next, it will basically run that script, and it's going to provide the following arguments to that script, which is simply just specifying to the script with 3 different flags that we want to reverse shell, what the IP address is, again, that will be ours, as well as the port. And so the port, once again, in this case will be 1234. I'm once again going to open a new tab, just so that before we forget, we open up our trusty Netcat listener on port 1234. So back to the command. And so this is the reason, guys, that we didn't specify our IP or port in the actual script, is simply because we provided to it at command line. So just briefly again, this payload will go, it will use PowerShell to download this script, it will execute that script, and as it executes it, it will provide these arguments to it, which will cause it to call back to our Netcat listener that we just created, and then hopefully we'll have a PowerShell shell on the victim system. Right, so let's run this. And so here we get our raw bytes, and the only thing we need to do now is we need to copy all this. So I'm going to copy, then let's head back to Sublime. And so here in Sublime, we can basically select everything from here to here. I'm going to erase that, and I am going to paste our new payload. Right, so these bytes are basically going to cause the other command to run that we just specified. And there's one more change that we need to make. Here we can see the server, which is basically the target system, is not correct. And so we'll just change that to the victim's IP, which is 10.10.10.74. And the IP is correct. As we saw, it was 9255 and 9256 for HAT, but that is actually the port that we want to send the payload to. So I'm going to save with Control S, and then let's get back to our terminal. So here on our terminal, I'll just clear. And remember that we do now both have our Python web server to make the script available, as well as our Netcat listener to catch the reverse TCP connection. And so now the only thing that's really left to do, friends, is to run the actual script. So let's go ahead and do that. Run Python exploit. And we see that we have a bit of issue, and like I showed in the previous video, whenever you see this syntax error, especially it's basically complaining that print doesn't have parentheses. And the reason for that is in Python 2, print didn't have parentheses, it only came in version 3. So we immediately know our issue here is we're using the Python 3 interpreter, not the Python 2 interpreter. And the very simple fix for that is just to specify Python 2. And it says poof. Let's go ahead and check in on our Netcat listener. Here we can see that indeed our script was served by a Python server. And so yay, you can see that we have our PowerShell shell, just what we wanted. So that's great news. So now guys, for the challenge, I'm not actually going to show the flag, but we are now the user Alfred. And so we can go now to Alfred's desktop and you'll find the flag there. Right, so now that we have a foothold on the box, quite obviously the next thing we'd like to do is to elevate our privileges so that we have admin or system level access, so that we can go ahead and get our final flag on the admin's desktop. And so our goal now with privilege escalation is going to be to kind of see if we can find stored credentials. Now there's a whole litany of different ways we could potentially find credentials. Sometimes some users simply store it in a text document somewhere. We could also attack something like the SAM database. But at the same time, I want to share a command here. And rage query is simply a command that allows us to search the Windows registry. Now specifically here, you can see HKLM, that just means H key local machine. This is just one of the top level keys in the Windows registry. That's basically pertains to everything related to users on this machine. So we're just narrowing our search down to this. And then the F parameter is just telling it we want to find. And what do we want to find? We want to find any instances of the word password. So let's go ahead and run our command. And we can see we have a lot of different results. And if we scroll through it, you can obviously go ahead and take your time. But something that pops out here is welcome one exclamation mark. And the reason it pops out is obviously because it really resembles what looks like a password. And then we can actually follow up with another rage query command, which can perhaps tell us what user this password actually belongs to. And so what you do is simply copy the name of this exact key, because we'll just run rage query, and we're basically just going to query for the complete contents of that key. And when we get it, we see that the password is welcome1. But perhaps a little bit disappointing, it is the password for Alfred. And in case you forgot, we are currently Alfred. And so perhaps this is initially a little bit deflating, but what if we take a moment and consider that perhaps this Alfred person is actually the administrator. But Alfred, he's not a very good administrator because he doesn't want to remember multiple passwords. And so despite Alfred having two different accounts on this system, one as Alfred and one as administrator, Alfred has this habit of just using the exact same password. And so we're going to try and see if perhaps welcome1 ! Is also the password of administrator. Now, I know initially when you hear something like this for a CTF or a challenge, it seems kind of a little silly. It seems kind of like cheating. But the thing is, this is obviously just a form of password stuffing. And it is actually incredibly realistic in the sense that this happens all the time. And so if we assume now username of administrator and password of welcome1 ! Well, what are we going to do with this information? Well, what we can do is actually kind of a different version of exactly what we did before, which was use the IEX command to go back to our machine and download the Nishang script and execute it, and then cause a reverse TCP connection to a Netcat listener. But this time, if we run it again as administrator, it means then, of course, that our shell will be an administrator shell. And this is, of course, one of the great kind of transcendent truths when we're looking for privesc, is if we can cause something to run as admin or as root and lead to a reverse TCP connection, lead to a reverse shell, that shell will de facto be an administrator or a root shell. Right, so the first thing I'm going to do, just to help kind of like tidy and clean things up, is I'm just going to define a new variable, and I'll paste it right there. And you can see that this variable is called cred. So PowerShell is not just the command line, it's a scripting engine. And so I can define this variable right now, cred. And so the value of this variable is really just an object containing the credentials, and the credentials that we are giving it is administrator and welcome1. And so as long as this session is active, whenever we write $cred, PowerShell knows what we actually mean is this value. And so let's just enter that. No feedback is good in this case. And so there's just one more thing for us to do. I just want to go back and double check. And yes, we still have our Python server running, which is great because we're going to need that. But let's open another new tab. And what we'll do, guys, is open another instance of Netcat. And the reason is, before we specified 1, 2, 3, 4, but that port is still occupied because that port currently has the reverse shell that is Alfred. And so we just need to create a new Netcat listener on a new port. So I'll use 1, 2, 3, 5. So let's get back to the victim system. And now on the victim system, since again we're in PowerShell, we can use start process to initiate a new process. And here you can see our arguments, and here you can basically see, friends, it is the exact same command as we ran before as part of our buffer overflow. The only difference here is that we've changed the port from 1, 2, 3, 4 to 1, 2, 3, 5. And one other thing is we are now specifying our credentials with the cred variable, which we just defined up here, and which has the credentials of hopefully the administrator. So let's run that. Now let's head back to our new Netcat listener, and you can see here we do have a PowerShell shell once again. And then let's run who am I, and you can see that we are administrator. Yeah! And so once again, friends, you can go to C users administrator desktop. You'll find the flag right there. I don't want to share it and spoil the fun for everyone. But if you did it, then congrats. You learned how to do privilege escalation with found credentials, specifically credentials we found by running an enumeration query on the registry. So yay. Alright friends, I hope you enjoyed that walkthrough. Please join me again soon for another walkthrough on privilege escalation because it will obviously be flippin' awesome. But until then,
peace out.